Hello, in this video we're going to be talking about no oxygen, respiration with no oxygen. So let's not waste any of your time. Let's get right to it. Alright, now when we're talking about respiration without oxygen, we're talking about obviously very either specialized situations, or in our case with fermentation, as we talked about, where we've worked or enough work has been done to where oxygen has been depleted, and now we're working without oxygen. But for the most part, when we're talking when we're talking anaerobic respiration, we're talking about a specialized pathway. Maybe it's bacteria can be deep underground. Maybe it's in a lava vent. Maybe it's under the ocean. But it's somewhere where oxygen is not available. And of course, most of this chapter has been devoted to with oxygen, aerobic respiration, where that electron carrier oxygen was part of that process. But now we're going to be looking at without. And two main types, as we can see: anaerobic, which just simply means without oxygen, and that, as we mentioned in the general information, that some inorganic molecule is going to be that final electron acceptor. You're still going to get your NADs, still got your FADs, but in that third protein, that where oxygen was, now it's going to be some other inorganic molecule. And of course, that's just going to be that main part was just going to be a nitrogen, calcium, chlorine, phosphorus, sulfur, something other than oxygen is going to be that acceptor. And if it's fermentation, then an organic molecule will be that final electron acceptor in the place of oxygen. And we know organic molecules got those carbon backbones, they got some H's connected to it. So we're more familiar with what those look like. And when that happens, fermentation happens, it can be converted into lactic acid or ethanol, and some carbon dioxide is released. Alright, so again, we're looking anaerobic. So if you think about methogens, or organisms that run off of methane, so their electron acceptor, instead of being oxygen as their final electron acceptor, it's carbon dioxide. So the carbon dioxide gets reduced to CH4, which is methane. And again, but again, the very diverse organisms. Cows can do this, as it says there. If you think about bacteria that lives in sulfur, so maybe it's in sulfur water, or maybe it's again in a volcanic situation. That inorganic molecule, sulfate, SO4, again gets reversed to hydrogen sulfide, H2S. So again, but we're looking at very unique situations that require a different pathway, because oxygen cannot be again found or not available. Again, so we're looking at, could be deep in the ground, could be in an area that just oxygen isn't available, out in the ocean, or in a sulfur-rich, whatever it could be. But again, the idea of without oxygen. Okay, but as we continue to talk about or think about fermentation, whatever the organic molecule is, in order for it to regenerate the NADs, because remember, we're still going through respiration, so all the other rules apply except for who that final acceptor is. Again, this process we're talking, yeast does this. It's the idea that's how it makes like bread or dough. Around here, it's pizza dough for the most part to rise. But again, you get the final products there. You get your carbon dioxide, your ethanols, your NADs are all produced. The lactic acid that I've mentioned a couple of times in animal cells, muscle cells. During hard work or exercise, you overwork your muscles and you get that stiffness, that soreness the next day. That's lactic acid. That was fermentation. You overworked the muscle and all the oxygen was depleted. But again, all the other rules apply. It's still respiration. The only change is who that final electron acceptor is. Alright, now the fermentation of alcohol. Again, each of these have their own kind of special little pathways, and we'll look at a slide that kind of showcases us all that. But again, we want to stress that this is still respiration. So you can see glycolysis there. You can see again, you're making those 2 ATP molecules. You're making 2 NADHs. So nothing changes in that. All we're really changing is that final electron acceptor at the end. But you can see the starting products, pyruvate, end product from glycolysis, and then we make some CO2s. We got some ethanol waste, and then of course the NADs. So again, we just want to stress these are not different topics. It's just the one change. No oxygen is available. So how's this going to happen? But with no oxygen present, no ATP molecules, no ATC to drop them off. So it's not as efficient. But it's just taking the bad situation and making the best of it as possible is one way to look at it. Alright, so that's our video for this time. When we come back next time, we will wrap up the no oxygen discussion for respiration. So we'll see you then.